I want to tell you about the universe. What it is, how it came to be, what its building blocks are. I want to tell you how the future creates the past, which then creates the future. But first, I want to tell you about crystals. You might be surprised to know that a crystal isn't an expensive piece of glass or a chandelier in some fancy dining room. The word crystal simply means a pattern that is periodic. Look at this checkerboard pattern. See how it continues to spread out infinitely in each direction? That means it's a periodic pattern. So that's a two-dimensional crystal. This is another two-dimensional crystal. And this is another. You can also have three-dimensional crystals. By the way, this 3D glass is called crystal because its atoms are actually arranged in a crystalline pattern. So, see how I'm projecting this three-dimensional crystal to a two-dimensional image on the sand? See how the 2D projection looks distorted because of the angle of the projection? That 2D image also has a pattern, but it isn't periodic. So, it's not a crystal. But there's a deep connection between the 2D object on the sand and the 3D mother crystal. This distorted 2D pattern is called a quasi-crystal. A quasi-crystal in a certain dimension, in this case 2D, is a projection of a crystal in a higher dimension, in this case 3D. A group of physicists in Los Angeles is working on a new physics theory where a particular 8D crystal, yep, that's right, an 8-dimensional crystal, is projected to 4D at a very particular angle, which forms a 4D quasi-crystal. And from this 4D quasi-crystal, they derive a 3D quasi-crystal, which they believe is the fundamental substructure of all of reality. This 3D quasi-crystal has a fundamental building block, a tetrahedron, which is a three-dimensional equilateral triangle. The size of each edge on this shape is the smallest possible length that can exist. This is called the Planck length. It's 10 to the 35 times smaller than a meter. So you know how your TV screen is broken down into building blocks called pixels? A pixel is the smallest possible indivisible unit of the 2D screen. So think of reality as your TV screen, but in 3D. And think of the tetrahedron as a 3D pixel, the smallest possible indivisible unit of reality. The tetrahedra in the quasi-crystal combine with other tetrahedra using complex mathematical rules to fill up all of the space in the universe. Each tetrahedron only has a few specific states in which it can exist at any given moment. And because of the rules of how these pixels connect to each other, if one tetrahedron is in a certain state, this dictates the states of many other tetrahedra throughout all of space. Now that I got my 8D glasses on, I'm gonna watch me some 8D TV. For some reason, this 8-dimensional thing, known as E8, appears to encode all of the particles and forces of our 3-dimensional reality. So let's talk about what E8 actually is. And what it is actually pretty simple. For reals. Imagine circles, all of them the same size. We draw them on a piece of paper stacked in the densest possible way that one can stack circles of the same size. This happens to be called hexagonal packing, by the way. Now, let's put a little point in the center of every one of these circles. And now, let's get rid of the circles and leave only their center points. So now, we have something called a point space. This point space is one that represents the densest packing of two-dimensional circles of the same size, right? Now, let's talk about the densest packing of 3D circles, or spheres. Again, all of them of the exact same size. P.S. We're totally pretending that these oranges are perfect spheres of the exact same size. So, the densest packing of 3D spheres is actually pretty intuitive to us. It's how we pack oranges in the supermarket. By the way, this is kind of weird, but it was only in 2014 that someone was finally... Now let's add points in the centers of all of our spheres while they're in this dense arrangement. And again, let's get rid of all of the spheres and keep only the points that represent their centers. Okay, so now we're left with the point space representing the densest packing of three-dimensional spheres. So far, so good, right? Y'all with me? Okay, so E8 is the point space representing the densest packing of 8D spheres.
E8 is a fundamental crystal. It's a fundamental lattice. In 2 dimensions, one of the fundamental lattices is the checkerboard.
Energy patterns of flow. Here we are walking next to the beautiful mosque with the filigree and all the ornate designs. Most people think that this is just an artistic expression. No. All the intricacy of all the wovens and all the locks and lattices and matrices come from the names of God out of the different scriptures. Because in the alphabet, in Arabic, Aramaic, Persian, Hebrew, which is Farsi, is Persian, it's Abjad numerical notation. It's about A, B, J, A, D. The alphabet is their counting system, which makes a mathematical lattice. It's a pattern, energy patterns of flow, all locked together.